Number one. Number one. Probably the most missed question yesterday. I was walking around the room. A lot of people had this marked for an answer. It is incorrect. The correct answer is C. We have to remember that they're looking for the rate per hour. Although they gave me 45 minutes, 45 minutes is 3/4 of an hour. Here's another question that they didn't ask from this, but I'd like to ask it. Is this a unit rate? Yes or no? Is it a unit rate? Yes or no? Can you tell me why?
It doesn't say 320 or 3/4 per hour.
Nope. Marcus.
Because the 3/4 isn't a 1.
The denominator has to be a what?
1.
Go Marcus.
If the denominator is not a 1, it may be equal to the unit rate, but it's not a what? Unit rate. This is equal to the unit rate. How would I make it a unit rate? Heat, change, flip. So 340 times 4 divided by 3. If you were doing it on a calculator. What's that come up to? 340 times 4 divided by 3. 453.3 repeating. And that would be toys per hour. That makes about right. Doesn't it look about right? If they could do 340 in 3/4 of an hour, that they're going to do more than that in a full hour. So it looks about right. Everybody with me?
Yeah.
Questions on number one? On number two, the correct answer is
Yay.
Yay!
Listen, as I walked around the room yesterday, I saw a lot of people mark these out as not being possibilities. And what they did when they marked these two out as not being possibilities is they said, well, it went from 6 to 12 to 20. And this went 6, 12, 18. This stayed constant. Remember that what we're calculating is K in each one of these. And K has to stay constant. And K is Y over X. And I actually have to work it for each piece until I find something where it doesn't stay what? Where it doesn't stay the same. In part D, if I do 225 divided by 6, it's going to give me 37.5. If I do 450 divided by 12, it's going to give me 37.5. And if I do 750 divided by 20, it's going to give me 37.5. So K stayed a constant 37.5 in D, and in all the others, K didn't stay what? Constant. Questions about number two? Number three is a simple interest problem, and they told me that. So I know I'm going to use this formula, I equals PRT. The principal is that amount, that initial amount that's invested. So the 3,500 is my principal. The rate is the percentage. This is my rate. And I looked for time in this problem, but it's not obvious, is it? What's the word that replaced time? It says what? What is the annual interest? What's my time? 1 year. Annual. So, principal, 3,500, times my rate, 0.023, times my time, which is 1. And the correct answer then for this problem was A, $80.50. Questions for number 3? This one asked for what was the simple interest, and I don't know how you would have come up with this unless you tried to multiply by a much bigger percentage, or you tried to add two numbers together, although if I tried to add these two together, if they wanted to know how much was in the bank, this would have been a better answer. Well, stop asking for help from them, because that didn't help then, right?
Help doesn't help. You multiply by 0.023, you just multiply by 2.3.
No. Why can't I multiply by 2.3?
Because you changed the decimals.
Right. Percent means what? Per 100. If I multiply by 2.3, instead of getting 8050, I'm going to get 8050. It's going to be 2 decimal places off. I've got to remember that percent means per what? 100, and I got to move that decimal 2 places.
I was going to say, can't you just move the decimal once you're done?
You can if you remember to do it, because how many places is it going to move? 2, always. So yes, you can if you remember to do it. Is it a good practice? Probably not. You'd be better off to move the decimal when you're multiplying it out. Number 4, they told me what type of problem this was. This is a percent of change problem, which means that I'm going to take the new amount, I'm going to subtract the original, and I'm going to divide it by the original. Okay? The new amount was 42,600. I'm going to subtract the original amount, which was 25,800. And I'm going to divide it by 25,800. If you do that on a calculator, this is going to come up 0.651 something. Okay? But how many places do I need to move the decimal to turn it into a percent? 2. That's why D is the correct answer. Questions on number 4? Yes? Do you have your work shown anywhere? No. Without knowing where your work is, I would say that B probably came up by, instead of dividing by 2580, you divided by 42,600. I would look at the percentage and say that's probably about what it would have come out to. Take these two and subtract them, then divide by 42,600 and see if that's what you come up with. But I bet it is. Okay? Just means that you've got to remember that it's what? New minus original divided by original. These two numbers are always going to be what? This number and this number are always going to be what? The same. Okay? Other questions from this problem? Can I go on? Number 5. A student spends the same amount each week for bus fare. In 5 weeks, he spends $115. Which equation shows the relationship? Let x be the number of weeks. We said to write an equation, at this point we're using y equals kx. And k would be the constant. And we find k by doing y over x. They said X was the number of weeks. So X is going to be replaced with what? 5. The Y must be the 115. When I do that division, 5 goes into 115 23 times. So in my equation, I replace K with 23, which is why C is the correct answer. Questions on number 5? Marcus.
This is one of the ones I got A. I think
Okay. So let's talk about this for a minute. If you put A down for an answer, let's talk about whether it's reasonable or not. They said number of weeks is represented by what? X. If I replace this with a 5, what should it end up being equal to?
Okay.
Should be equal to what? 115, right? Is this going to be 115? No. So I could have gone through any one of these equations and replaced X with what number? 5 to see which one made a true statement. And the only one that's going to be true is which one? C.
Can there be 3.22 weeks?
Sure. There could be. If it was 3 weeks and a day and some hours, it would be possible that we'd have 3.22 weeks. It's not how we typically refer to it, though, is it? If we would refer to weeks that way, we'd typically convert the weeks to what? The smallest unit that it actually would break down to. If it was a day and a part of a day, we'd typically break it down into hours. And if it was a week, a few days, a few hours, and a few minutes, we'd break it all down to what? Minutes, the smallest unit, so that it would all be the same, typically. Okay? Number 6. A store marks up sporting goods 27%. Which expression equals the retail price of the item with the original cost of P? We normally would spend 100% to purchase an item, but they've marked it up 27%. So I'm now paying 127% of the cost of the item. How many places would I move the decimal? 2. So this becomes 1.27, and I'm going to multiply it by that original cost, which is why D is the correct answer. Questions on number 6? Yes? Okay. If you marked A, this will only equal how much it was marked up. What would I have to add back to it? I'd actually have to add what to it? The original price. I'd have to add the P back to it to make it work out. Correct? This shows the actual markup, which is why I say as a shortcut, what do we add to the markup? 100%. And if I look at this, P plus 0.27P, what do these both have in it? They both have a P in it. If I took it out, this would be P times 1 plus 0.27. What's 1 plus 0.27? Do you see that it still works? But I've got to add what back into it? I've got to add the price back into it. Otherwise, all I'm paying is the markup, not the initial cost. Okay? Number 7. Should have ended up with 133.75. This was a multi-step problem. Had to do more than one thing. It said the price of a $250 coat increased by 7%. If it started out at $250 and it was going to increase by 7%, I'm going to multiply by 1.07. Why 1.07? And it still includes what? 100% of the original, right? If I multiply that by 1.07, it's going to give me $267.50. That's what it's going to give me. It says the coat is now on sale for 1/2 off. If I'm taking half off, how much of it am I paying for? 50% or paying for half of it, right? If I'm paying for half of it, I need to divide this by what? 2. It'd show me how much I'm taking off or how much I'm paying for it. And I should have ended up with $133.75. Okay? Questions?
Well, I just do the 1.07. I left out the 1.
You left out the 1.
Yeah, but then I just added it on to 250.
And you can do that. It's okay to do that. Again, if I look at this problem, I can add what back into it? The price. I can do that. Why do I use this method? It's a little quicker, that's all. No other reason. Number 8 should have ended up with $197.40. Again, a multi-step problem. At the end of the summer, a store marks down all the outdoor furniture 18%. A family bought 4 chairs in June at $35. Is June at the beginning of summer or the end of summer? Beginning. So the $35 must be what I paid for those chairs. If I paid for 4 chairs at $35 a piece, I paid $140 for those chairs. It said then they bought 2 more chairs when they went on sale. So what do I got to figure yet? The sale price. When I go to figure the sale price, I know that it was $35 originally. If I take 18% discount, I'm taking 100 minus 18, or 82%. So I'm going to multiply this by 0.82. So the cost of each chair now is $28.70. If I multiply 2 times 28.70, it's going to give me what? $57.40. And what do I have to do with those 2 numbers? Add them together. Questions on number 8?
I got 97.40.
You got what?
97.40.
You lost the 1 out in front? Do you have your work anywhere? Okay, I can't help when there's no what?
I forgot to add the 100.
I don't think it would have come out that way if you forgot to add the 100. Somewhere you just forgot the what? The 1 out in front. And I can't explain how, except probably it was keyed in wrong on the calculator. And I'm going to tell you, this is why it's really important that when you go to take your test tomorrow, that you write down these pieces so that it shows that the 4 times the 35 was what? 140. That way, if you come up with a weird answer at the end, I can give you credit for the pieces that you've done right. And I know that I talked about it last test, but I'm going to tell you again, the people that are organized with their work, even if you skip a question on your sheet, if they're numbered, They're organized. It makes it easier for me to find the work that you did for that problem. Makes it easier for me to give you partial credit if you missed it. I am not going to spend hours hunting for where the problem is. Everybody get that? So you should be what with your work? Organized. It shouldn't be all over the place. Number 9. You should have ended up with 8,360. Out of curiosity, how many people had 360? Okay? It's possible. But I'm going to tell you, if you ended up with 360, it wasn't a math problem, but a what? It was a reading problem. And it says, what is the total amount after 3 years? If I'm investing money, right? Whatever I put in at the beginning, do I want to have more or less when I'm done? I want to have more. So if they want the total amount at the end of the 3 years, I hope that it's more than what I started out with, 8,000, right? It is an interest problem. I equals PRT. P is the principal, which is 8,000. The rate is 1.5. How many places do I move the decimal? 0.015. T is time, which is going to be what? 3. When I work this out, my interest is $360. That's how much more money I should have. What do I have to add to that? The 8,000 that I started with. Questions on number 9? Number 10. If a person bikes 2.4 miles in 10 minutes, how far can he bike in 1.5 hours? The answer should be and I'm going to tell you, I saw a lot of creative ways to work this out. There's nothing wrong with creative methods of working it out so long as the creative method will work how much of the time?
1,000%.
All of the time, right? I know that if we use unit rates that I can always use unit rates, so that's what I did. This was given to me in hours, but this was given to me in what? Minutes. I changed 10 minutes to 1/6 of an hour. And I converted this to a unit rate. I took 2.4 miles and I divided by 1/6 of an hour. This way I'd get miles per hour when I was done. Okay? Keep, change, flip meant that I was going to take 24 times 6, 2.4 times 6 over 1, which gave me 14.4 miles per hour. And how long did I ride? 1.5 hours, so all I had left to do was multiply that by 1.5. It did give me 21.6. Yes?
I did it a different way.
Yes, I've seen a lot of ways of doing it.
Since I realized that half of an hour is 3 minutes, or I'm sorry, 30 minutes,
Mm-hmm.
and then a whole hour is 60 minutes, and so that's 90 minutes. 90 minutes divided by 10 equals 9 times 2.4.
And you certainly could have done that. And the only reason I caution against it is these two numbers sometimes don't go into each other evenly. And if it doesn't go into each other evenly, will your method work now? But you can always use what? A unit rate. Okay? And I try to teach things that work all of the time. Nothing wrong with that method. That method is much quicker in this problem. I didn't even think of it. So I applaud the people that did. Nothing wrong with it. It's a valid method. There's nothing wrong with it. But I did unit rate because unit rate works how much of the time? All the time, right? Number 11, it says, explain how to simplify this complex fraction. There's probably the simplest explanation. What are we going to do? Keep, change, flip. I'm going to keep the 330. I'm going to change the division to multiplication. I'm going to flip the 3/4. When it's set up this way, what can I do? I can cross cancel. 3 goes into 330, 110 times. And when I multiply this out, it gives me 440. They did ask me to do one more thing. Interpret the meaning of the results. What does the 440 represent?
Pages per hour.
It represents the number of pages that I can read in 1 hour. It's a unit rate. Okay. How did you do it?
Well, I changed the 3/4 and the 75 and then I divided it.
That's okay. And the only reason, again, I would recommend using the fractions versus the decimal, does every fraction change to a nice, easy decimal to work with? No, because 1/3 would be what? 0.3 repeating, right? So be careful when you're changing fractions to decimals. It doesn't work all of the time, whereas keep, change, flip works how much of the time?
100 million times.
All the time. Okay? But certainly nothing wrong with changing it to a decimal in this case. Going to get the same answer. Questions on 11?
It's kind of funny because we're working with percents and you want to say more percents. Sorry.
Okay. Listen, number 12 asked me to find two things. They asked me to find K.
The constant proportionality.
What?
Proportionality. And they asked me to write an equation. When we were talking about the constant of proportionality, we learned two equations. K equals y over x, and y equals kx. And we said when we're writing the equation, the only thing we needed to know was what k was. So the first thing I have to find from this table is the value of k. K is equal to y, 160 over 25. I could have picked any of the other pairs. It would not have mattered which pair I picked because k should stay what? Constant, should stay the same. It certainly would have been okay to use 32 over 5. It's also okay if you used the decimal equivalent, 6.4. Either would be acceptable. That's K. Y equals 6.4x. There's my two answers. Questions on number 12? Number 13. A car traveled at a constant speed of 45 miles per hour. Make a graph to show how the distance traveled in miles is related to the time in hours. And I'm going to tell you, I saw a tremendous amount of people go to this graph and say, well, at 1 hour, that'd be 45, that'd be about there. 2 hours would be about 90, that'd be about there. 3 hours would be somewhere in, and there's nothing wrong with that. But every one of those dots that I put on there are only a good estimate, aren't they? I looked for a dot that I knew for sure that I could claim on that graph. I know for sure that it's going to go through 0, 0. That's 1 point, for sure. I took 1 times 45, it wasn't on the graph. 2 times 45, it wouldn't really be on the graph, right? Not exactly. But when I went to 10 times 45, that would be exactly 450. So I went where the 10 was, and I went up to the 450, and I plotted that point. If I have 2 points, I have enough to create a line, and all I had to do then was connect my dots. It really should have an arrow on the end, showing that it goes what? On and on forever. Should it have an arrow on this end?
No.
Can you tell me why?
Because that's where you started.
I can't go negative miles. I also can't go negative what? Time. Can I?
Yeah.
Okay. Number 14. An object travels 4/5 of a mile in 1/2 of an hour. What's its speed? 4/5 of a mile? Half of an hour. That'll give me miles per hour. What am I going to do with this fraction? Keep, change, flip. I'm going to keep the 4/5. I'm going to change the division to multiplication. I'm going to multiply by 2 over 1. 8 over 5 would have been okay. You could have changed this to 1 3/5. That would have also been okay. Or you could have written this as a decimal, 1.6 miles per hour. Questions on 14? It doesn't say a car.
Well.
UFO.